Good morning. I gave a quiz over the weekend, and guess the first thing that I'm going to do is go ahead and go over that. I've gone ahead and drawn a picture of the physical situation of the quiz, and I'll answer all of the questions. I'll work out all of them here on the board so that you can see how it goes. Feel free to call. You've got my number several times on announcements. Give it a call if you need any help. And here, I'll go ahead and go through it right now. So you've got two blocks that are sliding on a frictionless horizontal surface. Block A is moving to the right, block B is moving to the left. I gave you the velocity of both blocks and the mass of both blocks, and I've got that information here. And then they hit and they stick together, and so this is after the collision, before the collision, after. We want to find the final velocity after the collision. That's one of the problems. We want to find the change in momentum of both blocks A and B. We want to find the change in the kinetic energy of the system before and after collision. There's going to be kinetic energy lost. We want to find out how much. We want to find out the force exerted, the average force exerted by one block on the other during the collision. I give you the time of the collision is 5 milliseconds, so I'll put that down too. So delta T, the time of the collision, is 5 milliseconds. Okay, so that's all the information. That's a picture of the physical system. Let's go for it. So this is a conservation of momentum problem. So the initial momentum has to be equal to the final. So the initial momentum of the system will be the symbol P, lowercase p sub I. So it'll be the mass of the first object times its velocity plus the mass of the second object times its velocity. So I have the masses here and the velocities. So that'll be 2 kilograms. That's the mass of block A times its velocity of 3 meters per second. Okay, plus that's the momentum of the first block before collision. The momentum of the second block before collision is 1 kilogram times its initial velocity, which is -5 meters per second. I noticed several people didn't include the negative sign. Remember, this is a vector quantity. Now, I'm not even worried about that here because it's one-dimensional. So just realize that a vector pointing to the right in one dimension is going to be a positive vector conventionally, and a vector pointing to the left would be a negative vector. And so this one has to be a negative vector, right? Momentum. So this is going to be 6 minus 5. So the total momentum of the system is 1 kilogram meter per second. The final momentum, and remember these have to be equal to each other, so the primary concept that we're dealing with here is conservation of momentum, and that's most of it right there. So let's go ahead and find the final momentum as well. That's got to be equal to the total mass of the two block system now, which is basically behaving as a single block. So it's going to be 2 kilograms plus 1 kilogram, so that's 3 kilograms times its whatever its final velocity turns out to be. We don't know what it is yet, so we need to leave it symbolic. Now if we set this equal to this, conservation of momentum, we get that 1 kilogram meter per second is equal to 3 kilograms times V final. So that leaves us with V final being equal to, if we take this 3 kilograms, divide both sides by it, we'll get 1/3 meter per second. So the final velocity of the two blocks, once they've stuck together after the collision, will be positive 1/3 meter per second. So it'll be moving to the right at 1/3 of a meter per second. So that's part 4. That's the fourth thing that's asked for. Let's see, let's find the change in momentum of block A. Well, that'll be the momentum of block A final minus the momentum of block A initial. Okay, so we really already have that. The final momentum of block A will be its mass of 2 kilograms times its final velocity, which we now know is 1/3 meter per second. Then we subtract from that the initial momentum, which is 2 kilograms times 3 meters per second, so that's 6 kilograms meters per second. Okay, and so this is 2/3 minus 6, which is going to be negative 5 1/3, or let's see if we express that, so that would be 5.33 kilograms meters per second. So this should be, and it's a negative value. Let me make room for a negative sign. So it's lost momentum. Block A has lost momentum. How much? 5.33 kilograms meters per second of momentum has been lost. The block was initially going faster than it was after the collision, so it's lost velocity, so it's lost momentum. So what about the change in momentum of block B? Well, it's the same story, right? It's block B's final minus block B's initial momentum. So the final momentum of block B is going to be its mass of 1 kilogram times its velocity, which is also positive 1/3 meters per second, because block A and block B are connected together now. Then subtract from that the initial momentum of block B, which was negative 5 kilograms meters per second. Remember, that's block B's initial velocity times block B's mass. The negative of negative is a positive, so it's going to be 5 plus 1/3, or positive 5.33 kilograms meters per second. And if you understand conservation of momentum, you should realize that once you get this answer, then you immediately know that the answer to this second part, by the way, this is, I think it's problem number 1, this is problem number 2. Problem number 2 should, without even a calculation, be exactly the opposite of problem number 1, as far as the answer goes. Block A has lost 5.33 kilograms meters per second of momentum. Block B must gain that much, because the change has to be 0, the total change in the system. So it drains out of one thing into another, but the total momentum remains the same. Now the kinetic energy change, that'll be K final minus K initial, and let's see, that'll be 1/2 times the total mass of the system, which is 3 kilograms, times its final velocity squared, which will be 1/9 meters squared per second squared. And then we have to subtract from that the initial momentum of the system. But now there's two things moving initially, so we're going to have two terms for the kinetic energy. That'll be 1/2 times 2 kilograms, the mass of block A, times its initial velocity squared, which is going to be 9 meters squared per second squared. Then add to that 1/2 times the mass of the second block, 1 kilogram, times its velocity squared, which will be 25 meters squared per second squared. So this is 12.5, and this will be 9, so 12.5 plus 9 is 21.5. And now this is going to be, let's see, 3/18, which would be 1 over 6, so 1/6. So this is negative, it's a negative sign here, 21.5 plus 1/6 would be negative 21.33 joules. So the total change in the kinetic energy due to the collision is 21.33 joules down. It lost that much energy, and that's what the negative sign represents there. Okay, so now the last part, we use that the impulse is equal to the force times the time the force is applied, and we know that time is 5 milliseconds. We want to find the average force, and the impulse is also the change in the momentum. Okay, so let's find the change in the momentum of block A. We've already found that to be negative 5.33 kilograms meters per second. We know the time, so the force acting on block A will be the change in the momentum of block A divided by the time of the collision, delta T. So that's negative 5.33 kilograms meters per second. Then divide that by the time of 5 milliseconds, or 5 times 10 to the negative 3 seconds. Now, a kilogram meter per second squared is a Newton, which is exactly what we wanted. So FA, the force exerted on A during the collision, should be equal to 5.33 divided by 5 would be negative 1.6, call it.